Okay, now that we know about skeleton equations, we have to also balance them. So we need to make sure that there are the same number of atoms of each element on the left side, also known as the reactants, and the product side, or the right side of that arrow. Because you cannot create or destroy mass, you have to make sure it is conserved, meaning that on the left side, you have the same number of each element as you do on the right side. So to write this balanced equation, you want to first write the skeleton equation, just like we learned in the last PowerPoint. Then you're going to use something called a coefficient to balance that equation, so that it is going to obey the conservation of mass. And that just states that matter cannot be created or destroyed. And matter cannot be created or destroyed, so that we are going to have the same number of elements on the left side as we do on the right side. So let's look at carbon burning in the presence of oxygen. And I really like this example because it shows you exactly how many atoms of each are in the reactants and the products. Once again, the reactants are on the left side, your products are on the right side, and they are separated by that arrow. And this equation is actually already balanced. So if you were to count how many carbon atoms you see here, there would be 1. On the right side, there's 1 right there, and that's it. All right, so 1 carbon on each side, that's looking good. Remember, we want to have the same on the left as we do on the right. So here in oxygen, you have 1, 2 of our oxygens. And on the right side, you also have 2 oxygens. So everything is balanced. You don't need any coefficients. So that one's already set. Now, most equations are not that simple. Let's take my favorite example of hydrogen plus oxygen yielding water. So on the left side, you have 2 hydrogen atoms in that molecule, 2 in our oxygen. But if you go to our product side, you have 1 oxygen and 2 hydrogens. So for the first time, we have an imbalance. We have 1 oxygen atom on the product side and 2 on our reactant side. So to fix this, we are going to use something called coefficients. So coefficients allow us to multiply the number of atoms that we have in that molecule. So let's pretend that we have 2 of our water molecules. So once again, on the left side, we have 2 of our hydrogens, 2 of our oxygens. And let's take a look over here. We have 1, 2 oxygens. All right, that's good. So we finally have the same number there. However, let's count how many hydrogens we have. Okay, so after counting each one of those hydrogens, we now have 4 hydrogen atoms. So that does not balance our equation. We now have to figure out how to increase the number of hydrogen atoms to balance that out. So what if we were to have 2 of our hydrogen atoms? So let's count once again. If we added 1 more hydrogen and kept the 2 water molecules, on the reactant side, we have 4 hydrogens and 2 oxygens, and you can double check that by looking at the subscript. If you were to take the coefficient, also meaning 2 hydrogen molecules, and multiply it by our subscript, we're going to get that number of 4 hydrogen atoms. With our oxygen, there is a subscript of 1, but we don't write those. So instead, we would just use the subscript here, and that is where we get the 2 oxygen atoms. Now on our product side, let's take a count. We have 2 oxygens, and if you were to take the coefficient and multiply it by the subscript of oxygen, that's going to give us our 2 oxygens. So finally we have those 2 balanced. Now once again, we're going to count how many we have of our hydrogen atoms. That is 4. And you can double check that by taking the coefficient and multiplying it by the subscript. So now we finally have the equation correct. If you were to rewrite the equation, you would have 2 hydrogen gas molecules plus 2 oxygen gas molecules reacting to produce 2 water molecules. And that's what you see in our picture above. So everything is equal. We have the same number of hydrogen and oxygen atoms on the reactant side as we do on the product side. So here are great rules that you want to write down in your notes. for balancing equations. The first is to determine the correct formulas, and I'll try and help you out as much as I can for that, for all your reactants and our products. Then you write your skeleton equation, remembering to put that yield sign in between and to put pluses or plus signs to separate different formulas. You're also going to then determine the number of atoms of each element in the reactants, followed by the product side. Then you will start to balance elements, one at a time using those coefficients, just like we did in the last example. Then we check to make sure all of our numbers are equal, because that has to follow the law of conservation of matter. Last step is to make sure that all of our coefficients are in the lowest possible ratio. So sometimes we accidentally make everything twice as much as we actually need. So if you can't reduce it, then you are all set to go. So let's try one. So a student suspended copper wire in the aqueous solution of silver nitrate. All right, so we have that already written down for us, and there's our copper wire. They noticed a deposit of silver crystals on that copper wire. All right, so there's our silver solid when it is reacted to form silver nitrate, which is aqueous. All right, so they already wrote our skeleton structure for us. Now we have to balance their chemical reaction. So the first thing I like to do is draw a line that separates our reactants, which are on the left, from our products on the right. Then I write down each and every single one of our elements to make sure that we know exactly how many of each are on each side. Then we start to count. So according to our equation here, Ag has no subscript, so that means it has 1. Nitrogen has no subscript, so that means it's also a 1. Oxygen finally has that subscript of 3. And copper again has no subscript, meaning there is 1. Now we are going to do the same thing on the product side. We have Ag, once again, no subscript, so that is a number 1. N has no subscript, but remember, if it is inside parentheses, you're going to distribute to figure out how many of each we have. So if you were to take 2 times that subscript of 1, you now have 2 nitrogens. Oxygen, you're going to do the same thing. You're going to take that 2 and multiply it by its subscript. And now we have a total of 6 oxygens on the right. And copper, once again, has no subscript. It is outside of those parentheses, so it has a number 1. Now we have to work on balancing. So first of all, Ag, that one's good to go. We don't have to worry about it. So let's look at nitrogen. Nitrogen, we only have 1. On the right, we have 2. So let's multiply each side by 2. So when that occurs, when you put a coefficient of 2 on the outside, it changes the whole quantity of silver nitrate here. So let's see. Before we had 1, I like to cross that out. Now we have 2 silvers, because our coefficient times the subscript would give us 2. We have 2 nitrogens, because before we had 1, now we multiply them. And last but not least, we have to multiply our 2 by our subscript of 3 to give us 6. And so now we have 6 oxygens and 2 nitrogens and 2 silvers. All right, so now our nitrogens, our oxygens are fixed. Our coppers, okay, those are still good. But now our problem is our silver. So let's see, do we want to work on the left side or the right side? I think I would add more to the right side. So let's put a coefficient of 2 next to that Ag. And that will cause us to have, instead of 1 silver, we now have 2. Looks like everything now balances. So our equation is finally balanced because all of our answers are the same for each element. All of the matter is conserved, and you are all set to go. So if you wanted to, you can go through your PowerPoint once again to check and make sure that is correct. And it has a nice way of going to tell you that your coefficients have to be in front of that compound in order to work, and they get the same exact answer as we had before. Let's try one more. So we have aluminum is good choice for outdoor furniture because it reacts with oxygen to form a thin protective coat of aluminum oxide. Here we are given our skeleton formula once again. So that's a yay step for us. We don't have to do that, but we do have to balance it. So let's take a look at how to balance it. We're going to do the same exact step as we did before. We're going to put a line straight down the middle and make sure that we write down each and every element that we have. So we have aluminum, and it has no subscript, so that means we have 1. Oxygen, it has a 2 subscript, so we're going to have a 2 next to it. Now we're going to look at the right side, or the product. So we have aluminum, and it does have a subscript of 2, so we're going to have a big old 2 on the right side. Oxygen, on the other hand, it only has 3. All right, looks like we have a mess here, so let's give this a shot. So aluminum, there's 2 on the right, so let's try 2 on the left. That's going to change how many aluminums we have in our reactant side. Since we have 2 here, we multiply by our subscript, which was a 1, to get 2. All right, now we're good on that one. Now here's a tough one. 2 and 3 do not seem to get along very well. However, if you were to find a common multiple of 2 and 3, you could find your answer. So some common multiples of 2 and 3 are, well, overall it would be 6. So if you were to take the 3 as a coefficient on the left side, that would give you 6 oxygens on the left. Now, how would we get 6 oxygens on the right? If you guessed 2, that's correct. We have to multiply our whole compound by 2, giving us 6 of our oxygens. Now that also does change our aluminum, so they're no longer balanced. Let's see how we could fix that. Well, first of all, our 2 as a coefficient on this side would cause us to have 4 aluminums over here. So on the left side, we would then have to have 4 as well. Overall, now we have the same number of all of our coefficients, all of our atoms, so we are all set to go. And it again is taking you through the same exact steps as we did before in your notes. And there's the same answer. So that will bring us to the end of this one, and I'll talk to you next time.